Okay, we're going to start with our next talk now, in which Philipp is going to talk about Seccomb, your next layer of defense. Enjoy.
Hi everyone. Who is already actively using Seccomb? Okay, that's not that many, but it's good because this is an introduction, so don't worry. So what we'll generally do is I want to give a bit of an overview of what Seccomb does and is how it's used in our product. So I come from Elastic, the company behind Elasticsearch and Beats. Those are the two ones where I will look at what we do with Seccomb in there. And then at the end, quickly how you might capture violations of Seccomb to figure out what bad stuff has happened. So let's see where we can take this. Oftentimes, this is our approach to security, where we accept that everything is fine. And this works for some time until something happens. And that something could be lots of stuff. It could be your instances start mining Bitcoins, or somebody steals your data, or whatever bad stuff could happen with your stuff. And then you figure out that nothing is fine and everything is on fire and everything is terrible. And we kind of want to avoid that bottom half where we say, what the hell is even our problem? And there are lots of solutions for security issues. And the one thing I want to point out is there are no silver bullets. And that's why I called it the defense in depth or in layers or whatever, is because there is not one solution you want to deploy, but you want to have multiple layers of protection. And also, nobody can sell you a tool that will make everything secure. That's nice for sales and nice to present to you, but it's not working like that. So you want to have multiple layers, and Seccomb is one of these potential layers that you can add to your applications. So basically the idea of Seccomb is that it can block specific system calls in your application. So basically your application can say like, hey, I know that I don't need these system calls, so I don't want to allow them for myself. Or put another way, you instrument the kernel to abort certain calls in your application or to kill the process entirely. So for example, even if you had a bad vulnerability in your code and somebody can do a remote code execution, they might not be able to fork off another process or call some other binary or bind a shell or whatever, because you just don't allow it in a Seccomb profile. So basically you're filtering out what system calls are possible from your application, because your application should know what it needs, and then you can filter out stuff that you don't need. So for example, if you know you will never need to fork another process and you disallow that, even if somebody hacks your code and you have a remote code execution vulnerability in there, somebody will not be able to start a Bitcoin miner as a separate process, because you can just not fork off that process. That's the general idea on what you probably want to have in your code at some point. It's pretty much an application sandbox. You can limit what you're doing in your application. That's the overall idea. Generally, this is not a new feature. So it was added in 2005 in general, like it's a bit different than what we have today. So the first version that was in there was you have proc, the process ID, and then a file seccomp. And if you set 1 in that file, you would enter a strict mode. And then your application would basically be limited to read, write, exit, and sig return. Because that's what a lot of applications just needed. You don't need to execute another binary. You don't need to fork a process. That is kind of like the first step. You know, our application is fine with those steps, so we are just limiting down to those. Then in 2012, basically the foundation was added to control system calls more finely granular. So you can actually register which syscalls are supposed to be allowed and which ones are supposed to be forbidden. And this was further improved, or especially the ease of configuration in 2014, when there is now a system call named seccomp. And with that, you can actually register which system calls are supposed to be allowed. So this is what you're most likely using today, unless you have a very old kernel somewhere. This is what you get. And just to quickly make sure where we are. So we have syscalls, and it's the one with the S to show you all the syscalls. And if you scroll into that, you will see that these are all the system calls that you could do. There are a lot over time. I'll just quickly jump to seccomp, and it shows you, okay, this system call has been added in kernel 3.17, as I've had in my slides. And then you could actually look into the system call, and then you can see what you can actually do here. So you can have that strict mode, that is kind of like that initial mode that we had, and then you can actually set a specific filter, or sometimes also called a profile, where you actually define in the BPF, the Berkeley packet filter format, what is allowed and what is not allowed from your application. So this is the system call you're using to actually register what is allowed and what is not allowed. And you could whitelist or blacklist depending on how you want to approach stuff. So let's break out of here again. Is anybody using that? Like any big applications? Probably quite a few of the applications that you're using on a daily basis are using Seccomb profiles already. So this is not a complete list, but this is one. So for example, you have Google Chrome using it. Also Flash running in Google Chrome would have its own Seccomb profile to try to filter out bad stuff. But you have it in other browsers, OpenSSH, Docker, Systemd, and quite a few others. So all of these are using Seccomb to kind of limit what you can actually do. How do you register a Seccomb filter then? So like we've seen in the man page already, it's written as a Berkeley packet filter, which is, I guess, nice for computers, but not so nice for humans to create and read, or at least not for me. But it is what it is. Is anybody using BPF anywhere already? For example, if you use TCP dump, there you could filter with the BPF format what you actually want to cover, capture or not capture. So BPF is widely used. You will run into it every now and then. I'm still not a friend of the syntax, but it is widely available and you will run into it. And then once you have registered a filter, every single system call that your application does is running through that Seccomb filter. Does it sound slow? No, it's not, because this is registered in the kernel, and this will never have to go to user land, but it can only stay in kernel land, so this is a very fast filter. But at first it sounds very expensive that you say, oh, we have an additional filter we need to call for every single system call, but since it's in the kernel, it is fast, and probably this is not what is making your application slow. So I wouldn't worry about that part so much. And the filter results have three possible outcomes. The first one is, it's allowed, like we didn't run into any deny rule that might block that. The process or thread can be killed. Like you say, hey, you're trying to do something where I know you should never do that. So just to be safe, I'm terminating the entire process. So we're just cutting you off. Or the third option is just to return an error for that specific system call, like the application still keeps running and will be around, but you filter out that specific system call and then log the error. So you can decide what should be the behavior. Kill the process, just block the system call, or everything is allowed and keep doing what you want. That is what you have in there. So like I said, I work for Elastic. We have our entire stack. Probably you've seen this one, ELK, or heard of that, Elasticsearch log/Kibana, and because the first letters make up this nice little ELK, that's what we always use for that. We have added another component over time, which is called beats, which is like a lightweight agent or shipper written in Go, which is basically like tailing log files, for example. The problem is there is no B in ELK, that's why we tried to get rid of that. And the first thing we tried is this, the BELK or the ELK B, which could look something like this. You can see it's a B, it's an ELK, the combination, but it doesn't really scale. So we didn't want to redo the entire branding, and then if we add another component, we want to redo that again. So we just call it Elastic Stack now, but if you say ELK, we still know what you mean. And the entire stack looks something like this. And the two components where we want to look into what Seccomb is actually doing is Elasticsearch, which is kind of our oldest component and where you store your data, and beats, that is the agent that runs probably on all your hosts or as a sidecar on your containers or as a daemon set in Kubernetes to collect data. That also uses Seccomb to filter out what is running because, well, since you roll that out on lots of applications or lots of nodes, you want to secure that. So Beats has components like FileBeat to forward log files and MetricBeat to collect metrics, and AuditBeat, we'll quickly look into that at the end, to collect auditing files. This is also how we will be able to figure out what Seccomb violations we have run into. So what do we have here? So in Elasticsearch, we are using or let me start over. Elasticsearch is a Java process. How do we get to the seccomp profiles, or how do we interact with those low-level system calls? Java has something called Java Native Access, JNA, and that is how you can interact with system libraries and do stuff like seccomp. And that is what we're actively calling there. And we have, it's a bit small, but probably you can see that we have a class bootstrap Java. And this is pretty much when you start up the process where we register that seccomp profile and allow or disallow calls as needed. Here, this is what the initialized natives, the calls we have here. It does a lot of things. One thing I always like to point out, even though it's not seccomp specific, it's this one here. This is a check that we always run if you want to run the server process as root. We will just system exit because we think that is a really bad practice, and sometimes people really want to run Elasticsearch as root, which we don't understand. But the only way to make this work, like run Elasticsearch as root, would be to fork the code and comment out this check. There is no other way to run Elasticsearch as root. Just saying, because this is also something that people run into every now and then. And then we have this call here, where we're trying to register the call and, well, reach out and configure seccomp as we need it. What we're actually doing here in the initialization, we're calling the different implementations for the different operating systems, because only in Linux it's called seccomp, but other operating systems have similar systems. They have different names, they behave slightly differently, but we do try to use them as well. I will just focus on seccomp, but you have similar things on Sun, on BSD, even on Windows you have something to kind of like filter down what system calls are allowed from your process. And we'll just initialize the one that is the right one for your operating system. It's just, I've added those to you so you can actually trace through the code and see how we call stuff. And we will throw an exception if we cannot register the system call here. So yeah, similar features, just different names on different operating systems. You can find the details in the source code, even though I'll brush over them for today. This is the one, and this is the BPF configuration now. That we register in Elasticsearch when you start it up. Yeah, for me it's still a bit of an arcane syntax, but luckily we have these comments on the side which might be very hard to read, but I'll publish the slides afterwards so you can read them there. What is kind of like the important part is here, what we disallow is fork and execute of the process Elasticsearch. So even if we have some bad stuff in there which we used to have in the past every now and then, especially around scripting, and people could fork another process out of Elasticsearch. This is not possible anymore because we just filtered it out. So nobody can start a Bitcoin miner by forking out some other process or bind a shell out of this here, because, well, the system call is gone. It's just quite a bit of configuration to actually make sure we have set that. And at the end, we're actually checking where we're able to register the seccomp filter. And if yes, we'll just continue and everything works as expected. In case any errors happen, we will actually fail the process, I think, even though I would need to validate that. So this was Elasticsearch. Beats is written in Go. There we have a slightly different approach. So for Beats, we have actually written our own library, the Go seccomp BPF. It's basically a nicer wrapper so that you can use YAML to configure seccomp. If you like YAML or not, that's a different discussion. But that YAML is pretty simple. And also you just call it from your Go code, so that's pretty simple to configure. What this looks like, or actually this is not what we are actually using. This is just an example here. Because what this does is it allows everything by default, but it disallows these calls here. So for example, connect to the outside world would be disallowed, which doesn't make any sense for Beats, because Beats is there to collect data and then forward it. Being a data shipper, you will need to connect to other systems. So this is not what Beats uses. That's why I added that context is not used by Beats, just to be explicit, because this would not allow us to forward any data. This is just an example. But this would be something, if you know, like you have some binary running that never needs to reach out to the network. This is how you could configure or filter out the system calls to actually not connect to anything or receive messages or whatever. So if you have something that doesn't need those, doesn't need to bind to an interface, doesn't need to listen. You could disallow that, and then all the network traffic or access has been blocked. What we actually have in Beats is it has a white or allow list. It is going on pretty long, and it's much longer. These are all the ones that we whitelist and allow. So it is more overhead to maintain this, because Elasticsearch had a different approach. There we just blocked the forking and execution part. Here we actually whitelist all the calls that you need. And this is a general rule here in libbeat, which is basically the base library. Specific beats might add specific permissions on top of that. So you can basically just merge more things into this array that allows that. But this is kind of the baseline that we maintain, that all the beats have these, and then you could add some on top of those. And only those are allowed, everything else is forbidden. That is kind of the approach that we have taken with beats here. So let's try something. So for example, let's run netcat. Let's bind to port 1025. If you have a computer open or a phone with a telnet client, you can do the same, because this is an online instance. You can just call it. So this is the domain Xera WTF, because WTF is obviously the right thing for any demo. And we connect to port 1025. I have actually opened that. So this is binding to any interface on port 1025. I can just connect to that, and then I can just say, hello, Philipp. And on the other hand, hello, Philipp is coming out. If anybody wants to try that out, feel free to send me a message, and I will receive that. So I will let that run for a moment if you want to chat with it, or actually we can kill that and instrument that a bit better. So what I'm doing here is I'm using strace to actually get a bit more insight into the process. Here I'm just interested in the binding of the process. So when I run this, you can see this is the call that is being run here. We have the bind call to that port, to that address, and then it is actually running. And we'll be using that later on to debug it if we actually kill or disallow something from the process. So what we have here is, we've seen this one, we've seen this one. I'm using the library called FireJail. Anybody heard of or used FireJail? So FireJail is the one that allows you to set out namespaces and seccomp sandboxes. And I'm just using that to, with one command line argument, actually secure my NC or netcat call to actually disallow the binding on the network interface, which looks just like this. So you can see we call FireJail with the no profile option, and then we set the seccomp drop rule that if it binds, it should not allow that one. And then we just call the process netcat on port 1025. So, no, this is not the one I want. This is the one I want. What will happen if I run this? Any guesses? Yes, it will exit very quickly. And it will tell us, well, seccomp protector enabled, and then it will tell you, well, it didn't allow that one. To actually see what is going on in there, we'll fall back to strace again. So here I'm using FireJail with the same thing, but here I'm adding strace again on the call. So when you run that, you will get a lot of output of everything that the system calls that are being done internally here. The relevant part is this one here. You see, you try to do the bind, and then you have the call or the process being killed, and that will actually be logged as well. So this is how you can very simply kind of like simulate setting a seccomp profile, and then a process being killed, and actually monitoring it with strace to see that this is not allowed. This is kind of the hello world example of seccomp and strace. And this is as far as we will push this for today. So, this is not where I wanted to go yet. No, most likely. So we have seen that one. And now, you don't want just to block everything, you want to collect what has happened in your system as well. So you want to actually see that somebody has run into a seccomp violation, and you want to get to that. So for that, you could use, for example, audit D. Anybody using audit D? No? It's a Linux auditing daemon. Basically, you can define some rules of what should be collected in terms of security events. It could be stuff like you were binding to some interface, you were accessing a file, you were executing a binary. It has its own interesting syntax to configure stuff, but in a Linux world, it's pretty widely used to actually see what is happening. And you could, by the way, look at what that looks like is if you say sudo or search. This is stuff that audit D would spit out. For example, here we have been, I don't know, we've been calling proc title and then we have collected a message and then it has some proc title that we have collected. Or you could see here, we have been running var run nscd socket. Here we have been running something on the path. So this is just all auditing information that the kernel can collect as well. Not part of Seccomp, this is audit D, but this is also very useful to actually figure out what bad stuff has been running on your system. The main problem here is to centralize these logs is a bit of a pain in the ass because every single line looks different than the other one. And to actually extract the meaningful information, you would need to write the regular expression here. Who likes writing regular expressions? That's the Stockholm syndrome, right? Where you get so used to actually doing some stuff that it's supposed to be the right way. I'm a bit lazy, and as a company we try to avoid some stuff that we don't like. So for that we have another beat called audit beat that is using Seccomp, but audit beat can actually get the audit D information. That's the entire idea. And we have another base library behind that. What that is doing is it's the Go lib audit library, and it's basically using the audit D data to not write that out to a file, but just get it in a structured format from the application right away, and then we can skip the regular expression part. But we can collect that, which then looks something like this. So if you've never seen it, this is Kibana. This is where we put stuff together, and we have recently added, I'll jump right to this part, we have added something we call a scene. This is basically the visualization of what we have collected with audit beat. So you can see here, audit beat has collected from my host 940,000 security events. For example, we have seen logins, that's probably failed SSH attempts and stuff like that. I know what packets are installed, what processes are running, what users I have, system log files. You could add other stuff like seek or bro, suricata logs. You could add stuff from your network devices. All of that can flow together here. And then you could just look at the outputs here. So you can see what has succeeded and what has failed, for example, and you can see which users have been running here. What I'm interested in, I'll just search for Seccomp because I know there was a Seccomp violation. And then down here you can see Seccomp has, for example, been called by the man page because, it wasn't a call for the man page. But what I'm more interested in is this one here. And you could just extend a timeline here, drop in that call, and then you see these were in the last 15 minutes because this is filtered down to just the last, the last 24 hours. This is when we ran that. We could open one of these here. I switch over to the JSON because this is the actual event that we have collected. And the relevant part is here. You see from the audit D module, we have collected something here, and you can see we have a Seccomp action that was the one that was triggered. And you can see which user was doing that. That is my user that has been running this. And somewhere in there it would say that Netcat was trying to do this. And here you have the actual event that has been collected by audit D. And then you can say, okay, I see here a violation has happened. We need to actually look into that user or that binary or whatever has been happening. So you can combine all of that here. So, since we're running short on time to wrap up. Security is generally made up of lots of bricks. So it's part of how you program your application, but it can also be part of stuff that you do on the operating system, including Seccomp or audit D, for example. Seccomp is generally widely available and used, so do use it because it's another nice layer of protection that might save your ass at some point. any questions? If you want stickers, by the way, on the table in the corner there, I have a couple of stickers, so just grab them. I think we have like 3 minutes or so left. So, questions?
This is library for developing your own stuff, but what about users? I'm using FireJail as browser protection and video protection. What do you think about the default profiles? Can you examine the default? Because they come with hundreds.
I mean, yes, FireJail comes with the profiles for various applications, and you could use them. But what do you mean? That the rules set per application?
Yes, they're developed by the community.
Yes.
So you examine how they.
I mean, I'm not sure I'm following the question fully, but you have on the GitHub repository, you have the code, and then you have the rules that people provided, and you can figure out what is available and if that works. If those are the perfect rules, I'm not sure, and it will also depend on the application. And part of the problem is it might work today, but if they have an update and then do some new system calls, your application might just fail, but that's just something you need to fix. Or depending on if you white or blacklist, because if you just blacklist, it might be fine. If you need whitelisting, it might be more tricky, but that depends on the rules.
So you can use blacklisting for specific.
Yeah, so for example, in Elasticsearch, what I've shown you, what we are doing there is blacklisting, whereas in Beats, we're using whitelisting. So you could use either approach, depending on how you register the filter and how to approach that then. Cool. Yeah. Wait for the microphone, please. Wait.
I have one technical question. We saw the setup of exactly configuration in the YAML file. Can you use the other type of configuration files for setup of the configuration?
Yes. I mean, so why we could use, so the syntax, kind of like the right syntax that is C-like, was, let me find the Elasticsearch example. This one would be kind of like the syntax that you would use in general. What we have basically done is we wrote the library for Go that will take the YAML configuration and just create the right BPF syntax out of that. So you could do that for any other programming language or JSON or whatever you want to write that in, but you would need to write it. So what we have done then is we have used, this is for example our library, that this is for Go, and then YAML to actually just provide, it tells you how to actually use it and how to generate the right Seccomb profile out of YAML through Go for the Seccomb BPF syntax. But this is custom stuff that we had to build.
Thank you.
Sure. I guess we have time for one final question. Otherwise, find me afterwards for more.
We have on every operating system something similar to the Seccomb. So my question is on Linux. Linux is more secure than other operating systems in some way. So is Seccomb a bit better than other operating systems?
That could be very much a trolling question. I'm careful not to answer this here. So to say, I would not say that Linux is the most secure operating system, because then
it's a bit more secure. I'm not good secure. I would not change.
Yeah, if you want to have a heated discussion with the FreeBSD folks, for example, you could say that. I'm very careful to avoid that here, because I might end up beaten up in a dark alley afterwards. So I would be very careful not to say better, because it's really just different. It's different approaches and different things you can do or cannot do. And this will lead to very heated discussions if you try to say that. So I would be very defensive and careful here, and I say, like, this is what Linux does, and this is how it works, and it probably adds a layer of protection for you. And other operating systems have something similar, which is called differently and behaves differently. But to be honest, also, I have never looked into the BSD or Windows implementation. So I would avoid any qualification of what is better or worse. Others have that as well. And I'm trying to not have a flame war here. Okay, cool. If you have any questions afterwards, just find me. Thanks a lot.